right, so now we're going to look at examples of analyzing confidence interval limits and also estimating sample size. All right, so the first thing we want to do is look at this example, analyzing confidence interval limits. It says, in exercises 9 through 12, express the confidence interval using the indicated format. Well, here they give us the confidence interval. They say they want us to express this confidence interval in this form, p hat plus or minus e. But they haven't given us p hat or e. So what I'm going to show you now is how to find p hat and e based on these numbers that they're giving you. And these numbers that you're given, this one over here, I'm going to call this the lower limit. The lower limit. So this is the lower confidence interval limit. And this one over here, I'm going to call the upper limit. Okay, now it turns out that because this confidence interval is centered around p hat, if you take the upper and lower limit and average them, you will get p hat. So it turns out that p hat is equal to the lower limit plus the upper limit divided by 2. So it's actually the arithmetic mean of the upper and lower limits. So we add them together and divide by 2, and that'll give us the middle of that interval, which is what we are calling p hat, because remember our confidence intervals are centered around the point estimate. So let's see, we have this is equal to, oops, this is equal to 0.720 plus 0.780 divided by 2. So it turns out our p hat is, let's calculate that, and that is 0.750. So we found p hat. Now e. Now we just need to find e, the margin of error. Well, we had a formula for finding e, but we don't have the information needed to find e. Well, it turns out that since the p hat is the middle of this interval, e is actually just half of the distance, because p hat is right in the middle. You go e above p hat to get the upper limit. You go e below p hat to get the lower limit. So basically, if you know the distance between the upper and lower limit, half of that distance is e. So to do that, what we can do is we can just take the upper limit, we can subtract from it the lower limit. That gives us the distance between the limits, and I want half that distance, so I divide it by 2. And that gives us, let's see, that's going to be 0.780 minus 0.720 divided by 2. So let's see what that, and that's actually equal to 0.030. So the margin of error is 0.030. So they want me to write this interval in this format, p hat plus or minus e, and here I found p hat and e. So to finish this question, all I have to write is p hat, which is 0.750, a plus and a minus, and then e, which is 0.030. So this would be the answer that they were looking for, p hat plus or minus e. But in this example, I've shown you how to take the confidence intervals limits and identify p hat and e. All right, the next thing we want to do is we want to estimate or find the required sample size. This is going to be the minimum sample size required to estimate a population proportion. Let's say we have a population proportion that we want to estimate. Well, we're going to have to go out and take a sample and then find the sample statistics. And from those sample statistics, we can actually create a point estimate. And that point estimate, we can then create a confidence interval. But we need to first take that sample. Well, how do we know how many elements of the population, how do we know how many things from the population we need in our sample? A good question. Well, this Little box here is going to tell us exactly how to find that number, that required sample size. All right. So the objective here is to determine how large a sample should be in order to estimate the population proportion. So we want to make an estimate of a population proportion. Let's say we want to know what the proportion of Democrats at Palm Beach State College is, right? Well, we need to know how many Palm Beach State College students we have to ask that question. We have to know how large our sample should be because we don't want to have to go through and ask this question of every single Palm Beach State College student. So the required notation, we know P is the population proportion, P hat is the sample proportion, N is the number of sample values, N is what we're looking for actually. This is our target. This is what we need to find, the number of sample values. E is the margin of error, and the Z of alpha over 2, that's the critical value that we spoke about in another video. So these are the notations that we're going to use. And here are the requirements. Well, the sample must be a simple random sample of independent subjects. So you must have a simple random sample of independent subjects. And if we know p hat, let's say we did a prior survey or prior sample, or let's say we spoke to some expert and he told us, hey, I think that the proportion of Democrats at Palm Beach State College is, I don't know, 48%. Well, in that case, we would use formula 7.2, which is really formula 7.1 solved for n. If you take formula 7.1, which showed us how to calculate the margin of error, and you solve it for n, you'll get formula 7.2 or 7-2. And we can only use this formula, 7-2, if we know p hat. So if we don't know or if we don't have an estimate of p hat, we have to resort to formula 7-3. And the only distinction between formula 7-2 and formula 7-3 is that in formula 7-3, we use the conservative estimate that p hat is about half. So we use the estimate that p hat is about 1/2, 0.5. And if p hat is half, then q hat is half, also 0.5, 1 minus 0.5, right? Which is also equal to 0.5. And when we find the product of p hat and q hat, p hat times q hat is equal to 0.25. So that's where that number comes from. This number here is 0.25 is really the product of 2.5s, or the product of 0.5 and 0.5. So if we don't know p hat, if we don't have an estimate already, we assume that p hat is 0.5. So let's take a look at this example. So this example, we have cell phones. As the newly hired manager of a company that provides cell phone services, you want to determine the percentage of adults in your state who live in a household with cell phones and no landlines. How many adults must you survey? That's asking us a question about the number of people that we need to survey or the size of our sample. Assume that you want to be 90% confident, that's the confidence level, that the sample percentage is within 4 percentage points of the true population percentage. I want to draw your attention to this phrase, to be within 4 percentage points of the true population percentage. Well, the definition of the margin of error is the maximum likely distance from the population proportion to the sample proportion. So what they're giving you there is the margin of error. You want to be within 4 percentage points. That's what you want to be the maximum likely distance from p hat to p. So that little phrase right there, within 4 percentage points of the true percentage, that little phrase right there is giving us our E. It's telling us that E is equal to 0.04 or 4 percentage points. All right, now let's go ahead and do part A. Part A says, assume that nothing is known about the percentage of adults who live in households with cell phones and no landlines. Because they're telling us nothing is known about the true percentage, we have no estimate. We have no estimate. So when no estimate p hat is known, we're going to use formula 7.3. So part A is telling us to use formula 7.3 to determine n. So n then is equal to the z of alpha over 2 squared times 0.025 or 0.25 divided by e squared. The only part of this that I don't know is the z of alpha over 2, the critical value. But that's easily found. I have 90% confidence. So what I need to do is I need to find the inverse norm of 1 minus alpha over 2 on our TI-83 calculator. So I'm going here, and I'm going to turn it on first. Let's clear this out. We're going to go to second, and then we're going to go to the distributions, and we want the inverse normal distribution. That's how we find our critical values. So number 3, inverse normal. And I'm going to do 1 minus alpha over 2, which, let's see. Oh, well, actually, I guess we should first find alpha and alpha over 2. So let's go ahead and find alpha first. Alpha is 1 minus the confidence level, which is 1 minus zero point 0.9, and that is equal to 0.1. Alpha over 2 is then 0.05, and what we're doing is we're going to do the inverse norm of 1 minus alpha over 2, or 1 minus 0.05. So we're doing the inverse norm of 0.95. That's what we're going to do on our TI. All right. So to find the critical value, we're going here. We're going to second. We're going to distributions. We're going to number 3, which is the inverse norm, and we're doing the inverse norm of 0.95. And this is going to give us the critical value. So the z of alpha over 2 then, the z of alpha over 2 is actually equal to 1.64. So we get 1.64. So now we have everything we need to plug into our formula to find n. N is then equal to the z of alpha over 2, which is 1.64 squared times 0.25 times 0.25 divided by e squared. Well, we just found that e, the margin of error, was 0.04 because it said we wanted to be within 4 percentage points, and this is also squared. So let's find out what this is equal to. So we'll take this and we'll plug all that information in. So we'll have 1.64 squared times 0.25 divided by, and then I'm going to put in parentheses 0.04 squared. Close the parentheses, and we get sample size of 420.25. Now, we're talking about a number of adults, right? So we can't have a quarter of an adult. But 420 is going to be too little because this required sample size is more than 420. So whenever you're determining sample size, always round decimal numbers up to the nearest whole number. So we're actually going to say that the required sample size here is 421. So n for part A is 421. That is the answer for part A. Now let's look at part B. Part B. Let's extend this a little bit. So part B. Part B says, assume that a recent survey suggests that 8% of adults live in households with cell phones and no landlines. So now we actually have information about, we have an estimate for p hat. So we have an estimate p hat. We already have an estimate from a prior survey. So in this case, we can use formula 7.2. And this should relax our requirements a little bit. Now that we have a little bit of information, our sample size that we require is probably going to be a little bit smaller. Let's see here. So now n, in this case, is going to equal, well, the z of alpha over 2 isn't going to change because it's still 90% confidence. We're still looking at the question with 90% confidence. So this is still going to be 1.64 squared. Now the only difference is instead of 0.25, I'm going to have the product of p hat and q hat over here. Well, p hat we just heard from the problem was 8%, so that's 0.08. And q hat then is 1 minus that, which is 0.92. So p hat is 1 minus q hat, and q hat is 1 minus p hat. So since p hat was 0.08, 1 minus that is 0.92, and we're going to divide this entire product by 0.04 squared. So only real difference here is this product, which up here is just 0.25. So let's see what this is equal to. Let's go to our calculator again. It's off. Okay, so let's see. In this case, we're doing 1.64. We're squaring it, and then we're multiplying that by zero point zero 0.08. We're multiplying that by zero point 0.9. Oops, parentheses. 0.92, and then we're dividing all of that by 0.04 squared. So let's close that parenthesis and press enter. And we get here that n in this case is only has to be 100, and we're rounding up again, 124. 124. So you see, if you have prior information, you need to survey less people in order to do the estimate. So that is how we're going to determine sample size uh, that is needed for estimation.